Welcome to Study Loop.
In this situation, you have two lenses, one convex, one concave. You do know the focal length for the first lens is 20 centimeters, and you know that it produces an image 20 centimeters away from the lens. And then you have, so this is a screen here, and this is my convex lens. And then you have this concave lens. It's being placed in between these two. And then you have to move this an additional 15 centimeters so that your image is still being produced on the screen, but now it's clear now that you've added that concave mirror. So to do this, we're going to assume that we have an object infinitely far away, and this helps us determine where the image will be for the convex lens. And so to do that mathematically, you can use the thin lens equation, solving for di. You do want to inverse the entire fraction, not just one bit of it. Again, infinitely far away means this is 0, which means our distance of the image is 20 centimeters. So my image is actually being produced right here where my screen is. Again, you can see that from the diagram. But if my image is on this side, that means my distance from my lens is now only 10 centimeters. But because it's on the right-hand side of my lens rather than the left-hand side, this DO2 is negative because it's on the right-hand side of my concave lens. So then using that information, again, we now move that screen back 15 centimeters. So now this distance was 10 plus 15 is now 25 centimeters. Now we can use that information to solve for the focal length of the concave lens. So using the same equation, so 1 over dO plus 1 over di equals 1 over f. Again, you want to inverse the entire fraction. And then make sure, again, that you are plugging in dO to be negative 10 centimeters. And then our image is, like we said, 25 centimeters away. And this gets us a focal of about 17 centimeters.